Hello everyone, I am Dr. VRAO-PHYSICAL. From the lecture 50, we came to know that electrochemical cells are not convenient for commercial purposes. Moreover, the disadvantages of electrochemical cells were rectified in commercial cells, right? And these commercial cells are broadly classified into three types, that is primary cells, secondary cells and fuel cells. Already we had gone through the primary cells. In this lecture we are going to learn about secondary cells, right? Secondary cells are those which can be recharged by passing electrical current through them, and we can use power again and again. I repeat, secondary cells are the cells which can be recharged by passing electrical current through them, and we can use them over again and again, right? So, secondary cells, the best examples for secondary cells are lead storage battery. What is that? Lead storage battery. Lead storage battery and nickel cadmium cell. Nickel cadmium cell. These are the two examples for best examples for secondary cells, right? Let us go through one by one, right? So, lead storage battery. Lead storage battery, it is most commonly used in automobiles. It is the most commonly used battery. It is most commonly used battery in automobiles, right? So, in this, this is a 12-volt battery. In this, 6 cells are connected in series. 6 cells are connected in series, that is why we call it as battery, right. So, you please find the difference between battery and cell. Already I told you, battery, when cells are connected in series, then it is called battery. So, lead storage battery, it is a 12-volt battery in which 6 cells are connected in series. 6 cells are connected in series, and in which lead is used as anode. Lead is used as anode, and lead oxide is used as cathode, and in this cell dilute H2SO4 solution, dilute H2SO4 solution, H2SO4 solution, it is more accurately 38% by mass sulfuric acid, and we can say it H2SO4 solution of density 1.30 grams per centimeter cube. Okay. So, in this cell lead is used as anode and lead oxide is used as cathode. H2SO4, dilute H2SO4 solution of density, dilute H2SO4 solution of density 1.30 grams per centimeter cube is used as electrolyte, right. So, and the cell reactions are usually what happens, what are the reactions that takes place in electrochemical cell, same reactions that takes place in also commercial cells. For example, in this cell, lead undergoes oxidation because lead acts as anode. What the reaction at anode? Oxidation takes place. Oxidation takes place. Okay, so in this lead at anode, lead undergoes oxidation, that is lead, solid lead plus SO4 2 minus aqueous undergoes oxidation. So, Pb undergoes oxidation which results Pb plus 2, and that Pb plus 2 combines with SO4 2 minus, and that is lead sulphate formed, lead sulphate, solid lead sulphate is formed plus 2 electrons. This is the reaction that takes place at anode. And at cathode, what happens at cathode? Reduction takes place. That is lead oxide PbO2 solid undergoes reduction. That is these 2 electrons gained by lead oxide and 2 H plus ions plus SO4 2 minus gives rise to PbSO4 solid plus water. Okay, water. So these are the reactions that takes place at anode and cathode. Okay, you please remember that in this cell, in this battery, 6 cells are connected in series. You please keep that point in your mind, because it is a battery. In this battery, cells are connected, 6 cells are connected in series. Okay, so and that is a 12-volt battery, and the reactions are lead undergoes oxidation and lead oxide undergoes reduction. Okay, if you find the reactions lead sulphate and lead sulphate, so the products of anode and the products at anode and cathode are same, but what happens, the products so formed at cathode and anode are same, but how the cell works, because when during the discharge of battery, what happens? Oxidation takes place and reduction takes place, but during this discharge, the density of H2SO4 solution, decreases. The density of H2SO4 solution decreases, because we cannot discriminate when the cell is exhausted, because the products are same at anode and cathode, the products are same, but during the discharging, H2SO4, the density of H2SO4 solution falls down. When the density of H2SO4 falls below 1.30 grams per centimeter cube, that indicates then in such situation cell needs recharge. So when the cell needs recharge, when the electrolyte density is less than, when the electrolyte density falls below 1.30 grams per centimeter cube, then cell needs recharge. So when cell needs recharge, we can pass electrical current through this battery. We can pass electrical current through these cells. Thereby we can recharge these cells. But during the recharge, cell reactions are reversed. reversed. Cell reactions are reversed, right? Cell reactions are reversed, that is, and moreover, and the cells are working as electrolytic cells during recharge. Therefore, during recharge, those cells are acts as electrolytic cells. How it possible? Because during the discharge, the products so formed at anode and cathode adhered to electrodes, right? And that products undergoes and the products undergoes reverse reactions during recharge. So, these are the reactions during discharge. These are the reactions during discharge, but during recharge, these cells are reversed. That is PbSO4 solid plus 2 electrons gives rise to Pb solid plus SO4 2 minus aqueous, right? Therefore, the sulfuric acid density increases, right? Next, another PbSO4 solid plus water gives rise to PbO2 solid plus 2 electrons plus 2 H plus SO4 2 minus aqueous, right? So, these are the reactions, these are the reactions takes place during recharge. So, this type of setup enable us to discharge the battery, that is, we can extract, that is, we can draw electrical current for our daily usages, and whenever the cell discharged and whenever the cell exhausted, we can recharge this cell, but during that recharge, the cell reactions are reversed and the cell works as electrolytic cell. So, this lead storage battery works as commercial cell, that is electrochemical cells and electrolytic cell. So, those two are possible in this lead storage battery, in this secondary cells, right? Another example for secondary cells are nickel cadmium cell. Okay. Another example for secondary cell is nickel cadmium cell. Okay, this is also a rechargeable cell, but this is a cell. In this cell, nickel cadmium cell, it is not called as a battery, because it is a cell in which a single cell is used, and it is more popularly used in calculators. Okay, the batteries that we are using in calculators are nickel cadmium cells, right? So, it is most commonly used in calculators in which cadmium is used as, and one more thing is that nickel cadmium cell is nickel cadmium cell has longer life than lead storage battery, right? Nickel cadmium cell has longer life than lead storage battery, but nickel cadmium cell is somewhat expensive. It is somewhat expensive, and in which cadmium is used as cathode, and nickel oxide immersed in KOH solution. Nickel oxide immersed in KOH or hydroxide solution, basic solution, is used as cathode, Okay. So, cadmium is used as anode and nickel oxide immersed in KOH solution is used as cathode, and the cell reactions are cadmium undergoes cadmium solid undergoes 2 OH minus ions, aqueous gives rise to cadmium hydroxide, aqueous plus 2 electrons. Here cadmium undergoes oxidation, that is cadmium undergoes Cd plus 2 due to oxidation of cadmium, that forms cadmium plus 2 ions, and that cadmium plus 2 ions combines with the OH minus ions, and that forms cadmium hydroxide solid, right, plus 2 electrons. Okay, and nickel oxide undergoes NiO2 undergoes reduction, that is 2 electrons plus nickel oxide undergoes 2 OH minus ions. 1 minute. Okay, 2 electrons plus 2 H2O gives rise to nickel hydroxide solid plus 2 OH minus ions. 2 OH minus ions. These are the cell reactions. Okay, so actually there is actually no need to memorize these equations, but we need to know cadmium undergoes oxidation and nickel oxide undergoes reduction. So cadmium undergoes oxidation, that forms cadmium hydroxide solid, and nickel oxide undergoes reduction, that forms nickel hydroxide solid. And the products so formed at anode, this is at anode, this is at cathode. The products so formed at anode and cathode are adhered to the electrodes, and that enables us to recharge the battery, because the products so formed at electrodes are adhered to electrodes, and that adhered products enable us to recharge the battery, because during the recharge cell reactions are reversed, and the products so formed in the discharge are useful in the recharging cell reactions, right. So cadmium hydroxide is a solid and nickel hydroxide solid formed at cathode, and cadmium hydroxide is formed at anode, right. So this is these are the reactions during a discharge. But when cell needs recharge, when cell needs recharge we can pass electrical current through them, that is we can recharge them, but during that recharge cell reactions are reversed, and cell works as electrolytic cell. So as in the case of lead storage battery, in this case also during the recharge cell reactions are reversed, and that enable us to recharge the battery, recharge the cell, because this is a single cell. Okay, so it is a cell with 1.4 volts. It is a cell with 1.4 volts current, right. So this is about secondary cells. Okay, if you are really like this video, please extend your support, like, share, comment and subscribe. In the next video I shall come up with fuel cells. Thank you for watching.